Hey, this is Mr. Kearns. In this video, I'm going to review graphing exponential functions and modeling exponential relationships. The way that I do this is a little bit different than Mr. Bruns. We still sketch these as transformations, but I try to avoid having to do a table. Okay. First thing I'm going to do is identify the parent function, which here I see as y is equal to 2 to the x. And then I'm going to, once I have the graph of this, I'm going to grab these transformations to get my final graph f. For that, I'll make a short table of the parent function for the values right around 0. So 2 squared is 4, 2 to the first is 2, 2 to the 0th is 1, and you can notice you're dividing by 2 each time, which makes this 1/2 and 1/4. I'm not sure if you can see those, it's kind of small there, but I have 4, 2, 1, 1/2, and 1/4. I'm going to put very light points in my graph where these are. So 2, 4, 1, 2, 0, 1, 1/2, 1/4. See, each time it multiplies by 2 going this way, and every time it cuts in half going to the left. And I want to take these 5 points, and now I'm going to do these two things to them. Follow order operations, I'll first multiply the y value by -3, and then I'll subtract 1. So let's see, this is a y value of 4. 4 times -3 is -12. Then -12 minus 1 would be -13. So this one's not going to fit on our graph. This y value is up 1, 2. So let's see, 2 times -3 is a -6. Subtract 1. And again, I'll make this point kind of big here. So this point reflected over and stretched out and then shifted down 1. See, this is a y value of 1. 1 times -3 is -3. Move down 1. Right there. I have 1/2. 1/2 times -3 is -1.5. Subtract 1. Right there. I get a fourth. A fourth times -3 is -3/4. -3/4 minus 1. Put me right here. So I can see my graph is looking kind of like this. If I continue this pattern and use what I know about exponentials, what I'm going to get is an asymptote. My graph looks like that. When I look right here, that tells me I have an asymptote at -1. That's my graph should never cross that. Domain here, I'm going to the left forever, I'm going to the right forever, which means I have all real numbers. For the y-intercepts, take a look at where the graph hits the y-axis, which is right there, which is at 0 and -4. For the second graph, I have a parent function of 1/2 to the x. Oops. Let's see. Alright, that one equals 1/2 to the x. See, 1/2 squared would be 1/2 times 1/2, which is a fourth. 1/2 to the first is a half. 1/2 to the 0th is 1. 1/2 to the negative first, let's take the reciprocal, it's 2/1 to the first, which is just 2. 1/2 to the negative second, take the reciprocal, I get 2/1 to the second, which is 4. Just got that up there. And graph these points. At -2, I'm at 4, 2, 1/2. So there's my parent function, the 1/2 to the x. And I want to move it exactly 1 unit to the left. So over 1, over 1, over 1, 1. I can connect these points. It seems like it's leveling off right about here. And there is a +0 at the end, which is why the asymptote is at y equals 0. For the range, it's everything that's almost to 0 and above. It never actually dips below here. So the y is greater than 0. And it's not a coincidence that I see the asymptote here. It's leveling off. And there's nothing being added on, and the range is greater than 0. To further connect it, if we describe this arrow, We're saying it's getting really close to this, but never actually dip below, which means as x goes to infinity, the y value is going to 0. So again, this 0, this asymptote, pops up pretty much everywhere. For end behavior, I need to describe both arrows. That was just one of them. If I describe that arrow, that's saying as we're going to the left forever. To the left forever is negative infinity for x. You're going up very fast forever, which is infinity for y. All right, for modeling exponential relationships, problem. When you initially bought your home, the purchase price is $200,000. Unfortunately, due to the poor economy, the home lost 2% of its value each year. Identify the variables in the units. X is going to be the number of years. And the y value is going to be the current or the value of a house at that time. Okay. Both these things change as time goes on, the number of years goes on, and as time goes on, the value of the house is decreasing, which is why I call them variables. For an equation to model a situation, here I'm going to use kind of a general form, y equals a times b to the x, where a is the initial amount and b is the growth factor. When we're dealing with problems like this, we actually have kind of a special form, which is the initial amount times 1 plus or minus the rate of growth or the rate of decay to the x power. In this case, if I change 2% into a decimal, it's 0.02. Moving the decimal place 2 places to the left. I'm adding 1 to it because, I'm sorry, that's a lie. I'm subtracting it from 1. Because each year, I basically keep 98% of the value. I have the whole 100% of it what it was, and then you're only taking away 2% at a time. I'm going to multiply that by the initial value of the house, which is $200,000. And I'll multiply it by x times. 200,000 times this thing, how many years it's been. So y equals 200,000 times 1 minus 0.02 to the x. I could do this. I would probably simplify this actually even further into, 1 minus 0.02 is 0.98. These will get the same answers. I kind of like this one better. Interpretation here means you get to keep all your money except for 2%. This one is kind of the glass half full, is you get to keep 98% of the value each time. I'll use that equation. How much is the house worth 5 years later? Well, that would be 200,000 times 0.98 to the fifth. Plug that in my calculator, and I get 180,784.16. Writing my solution in a sentence, it means after 5 years, the house is worth $180,784.16. It lost about $20,000 of value in 5 years. Sadly, not too unrealistic. Last part here, just as in linear, is to identify the parameters. Now here, we are not going to have slope. All right, slope is something that we talk about for linear because it's always the same. For exponentials, the slope is actually always going to be changing, so it doesn't mean as much to us. Reminder, the parameters are basically the numbers in the equation that do not change, that have a specific meaning. So in this case, $200,000 is the initial amount, or the y-intercept. And this means that that was how much the value was. This means the house was valued at $200,000 when it was purchased. And that covers the 200,000. The 0.98 is what we call the decay factor. And it means the house is only retaining 98% of its value every year.